What's up, people? How's it going? I hope you guys are doing fantastically well, taking care of yourselves, and in the midst of your preparations. I hope your preparations are going at full-fledged right now. For CBSE students, the dates have been announced, so I hope you guys are aware of it. For ICSE students, I'm not really sure when it's going to be, but it's going to be somewhere around that time. For CBSE, it's around 26th of April, if I'm not wrong. So for ICSE also, it should be around that time. So you have a good amount of time for your preparations, guys. So don't panic. But yeah, there's no official word from the CISE board yet, but I'm hoping that it's going to be somewhere around that time. So don't panic, stay calm, but at the same time, make sure that you prepare well. You have enough time right now to complete at least 2 or 3 cycles of revision, so make sure that you do that as well. So once again, a very warm welcome. My name is Anoop and this is Vedantu's 9th and 10th English channel. Before we start, subscribe to the channel, hit the like button, and make sure that you guys spread the word. Tell your friends about this channel as well, so that they are also aware of this, that there is something called as Vedantu 9th and 10th that exists. All right, so a very warm welcome once again. What we're going to do in today's session is going to be very simple. So if you guys remember, people, in the last video that came out for ICSE students, we had done the first part of current electricity. In that first part, we learned about what is current, what is potential difference, what is Ohm's law, what is resistance, what is EMF, terminal voltage, and internal resistance. In today's session, we're going to cover the rest of the chapter. So we'll be completing the whole chapter of current electricity in the next 45 to 1 hour, where we'll talk about what are the combinations of resistors, what are the formulas I need to remember, electrical energy and power, and heating effect of electric current. Now, I'll tell you one more additional fact, guys, a bonus tip I would say, is this, that I have already done these topics for CBSE students, and it's very similar to for ICSE as well. So if you guys need more clarifications, you can always watch the recordings of that as well. Be it combination of resistors, be it electrical energy and power, and heating effect of electric current. I've done separate videos of this, so you can always refer to that. There's nothing demeaning about it. It's the same topic for ICSE as well as CBSE, so you guys can actually get a good amount of help from that as well. Right, guys? So without wasting much more time, let's get it on the topic with the first topic in our hands, which is nothing but resistors. So in the last session, guys, we understood what is resistance and what are the factors affecting resistance. But what we did not talk about are the real world scenarios. Because for example, guys, imagine you have an adapter with you, right? A simple phone charger or a mobile charger, or it's the same thing, right? A laptop charger, right? Whatever the charger is, whatever the adapter is, imagine that there is an adapter with you. Now, do you think in that adapter there's only one resistor connected throughout the entire circuit, whatever that the IC circuit is? Do you think only one resistor is connected throughout the entire thing? Obviously not, right? There'll be several number of resistors connected over there. So when you have several of these kind of resistors, we can either connect them in series or we can connect them in parallel. And that's exactly what we're going to talk about right now. Now, this is a very important topic with respect to your numericals also, because time and again you can expect the numericals from this topic has been repeated. If you have gone through your previous year question papers, you can see several examples where the same either series or parallel combination have been repeated. So make sure that you pay attention, stay till the end, and make sure that you listen to everything and note down everything that is important. Let's start with series connection. What exactly is series connection? Imagine, guys, I have 3 resistors. I have 3 resistors, R1, R2, and R3. And let's say that I have put these resistors one after the other. After one resistor R1, I'm putting another one which is R2, another one which is R3. So when they've put one after the other, when you've connected a resistor one after the other, that is what is known as series connection. Series in the sense one after the other. This is what is called a series connection. All right, one after the other. Now, here there are 2 things. There are 2 key takeaway points that you need to remember. The first thing, guys, is that in series connection, current will remain exactly the same. Because just think about it, people. So current is always flowing from positive terminal to the negative terminal, right? So if you look at this, the same current I will flow through, because there's no other path for current to flow. There's only one single path. It's like this. Imagine that you have to go from your home to your school, people. Imagine you have to go from your home to school. But let's say that the path that you have from your home, let's say this is your home and this is your school, right? Now, the path that you have to go from your home to school is just one path. Now, no matter how treacherous, no matter how bad, no matter how worse the traffic is, since there's only one path, you are forced to go through that path. There's no other path you can flow, you can go through. So that's exactly what happens in series connection. Here, since there's only one path for current to flow, for the charges to flow, there's no other way. All the same current would be flowing through R1, the same current would be flowing through R2 as well as R3. So in the case of series connection, please do remember this, people. The current always remains constant. It always remains same. So if you take the current flowing through R1 as I1, and the current flowing through R2 as I2, and the current flowing through R3 as I3, here all of them would be the same. So whatever is the total current I, that will be equal to I1, that will be equal to I2, that will be equal to I3. So it's basically the same current flowing through the entire connection, if in case they're connected in series. However, in series connection, voltage across the resistors will be different. For example, imagine there are two resistors, R1 and R2, connected in series. So let's say that the voltage across resistor R1 is V1. All right, resistor R1 is V1. So this here is V1, and this resistor, the voltage across R2 is V2. Now, if you just pay attention for 1 second to this circuit diagram, you can see that, guys, R1 is actually connected to 2 points. R1 is connected to A as well as B. Now, what is potential? What is electric potential? It is nothing but the work done to move a unit charge from one point to another. So if you calculate the potential across R1, if you connect a potential, a voltmeter at that point, so what happens is that you'll be connecting to 2 points, A and B. Now, the potential at A will call it as VA, and the potential at B will call it as VB. So what is V1 equal to? V1, which is nothing but the potential across R1, that is equal to potential at A minus potential at B, because you're finding out the potential difference. So we are assuming that one is at a higher potential and the other is at a lower potential, and we are finding out the work done to move from one point to another. Basically, that's what we're doing. So V1 is equal to VA minus VB. Now, if you take R2 as the resistor, now here R2 is connected to B and C, 2 points B and C. So if you take VB as the voltage at VB at B, and VC as the voltage at C, here what is V2 equal to then? V2 will be equal to VB minus VC. All right. Now here, guys, the total voltage. Now if you talk about these two ends from A to C, if you talk about A and C, the 2 points A and C, what is AC? That is nothing but voltage across A minus voltage across C is nothing but the total voltage applied by the battery. Whatever is the total voltage applied by the battery, whatever is the potential difference applied by the battery, whatever is the the terminal voltage or the EMF of this particular cell, that will be nothing but V. So VA minus VC, which is nothing but the two ends that you have, two resistors combined together. So voltage across A and C, 2 points A and C, that would be equal to V. So you can say that V1 plus V2 is equal to V. Right, because V1 plus V2 is nothing but, if you just add V1 plus V2, V1 is equal to what? VA minus VB, and V2 is what? V2 is nothing but VB minus VC. So when you add them up together, so V1 plus V2, VA minus VB, plus what will you get? VB minus VC, VB minus VC. So here VB gets cancelled. So what are you left with? VA minus VB. Simple. So that's what you're showing over here as well. So VA minus VB is nothing but V, because that is the potential applied by the battery. Simple. So when you add them up together, you will get it as V1 plus V2 is equal to V, because VA minus VC is nothing but V. That is nothing but the potential difference applied by the battery. All right. I hope it's making sense, people. It's a very small derivation, but yet something that can be asked for 2 to 3 marks. So pay attention, right? Now what we're going to do is, people, we're going to apply Ohm's law. So we know that Ohm's law, according to Ohm's law, we know that V is equal to IR. So V is equal to IR is what is Ohm's law, right? So here, people, V1 is nothing but I1 into R1. And V2 is nothing but I2 into R2. And V is nothing but the total current flowing through it, which is nothing but I, and the total resistance. So here the total resistance, both R1 and R2 together, that's total resistance, we will call it as R equivalent, which is nothing but, instead of, see, what is equivalent resistance? Nothing but, instead of connecting two separate resistance or resistors which has certain values, what we are trying to do is that we are going to replace it with one single resistance which has the same value as them being connected one after the other. understanding. In the sense, for example, in simple words, it's nothing but instead of writing, let's say you're doing you're doing a numerical, instead of writing throughout the entire derivation as 3 plus 5, you can directly write it as 8, right? It doesn't change the value, isn't it? 3 plus 5 is also 8, and if you write it as 8, that is also still 8 itself. So basically what we're trying to do is that instead of writing it as R1 and R2, what we're trying to do is that we are trying to simplify the circuit. So what we're trying to do is that we'll just try to make this as one single resistance of equal value of resistance, equal value of current, and equal potential difference, which we'll call it as R equivalent, which means it's equal to what R1 and R2 were providing when they were connected in series. All right, that is what is called R equivalent. So once you put down over here, guys, now we know that I1 is equal to I2, which is equal to I. So in place of I1, I can write it as I. So this will be I into R1 plus I into R2, which is equal to I into R equivalent. So from here, people, you can clearly see that I gets cancelled. So what are you left with? R1 plus R2 is equal to R equivalent. This is the formula to calculate the equivalent resistance when the resistors are connected in series. So if you have resistors connected in series, the equivalent resistance is equal to, that is, the total resistance provided by these resistors connected one after the other is called as the equivalent resistance, and that is equal to R1 plus R2. If you have 3 resistors, then it's R1 plus R2 plus R3. If you have 4, then R1 plus R2 plus R3 plus R4. If you have n number of resistors, then it will be nothing but n into R. All right, n into R, where n is nothing but, for example, imagine you have 100 resistors, or each of 2 ohms, 100 resistors connected in 2, each of them are having a value of 2 ohms. Now it doesn't make sense for me to write it from R1, R2, R3 till 100. So instead what we can write is, if you have n number of resistors, R equivalent is equal to n into R, where n is the number of resistors, in this case is nothing but 100, and R is the value of resistance, which in this case is 2 ohms. So the total resistance you'll get it as 200 ohms. So basically when you have n number of resistors, this is the formula that you would be using. R equivalent is equal to n R, which is nothing but n is the number of resistor, R is the value of resistance. Now the key takeaway points from what we have learned so far is, guys, this is what you need to remember. First thing is that in series connection, the resistors are connected one after the other. So you see this, one end of one resistor is connected to the other end of the other resistor. So one end of one resistor is connected to the other end of the other resistor. This is what is series connection. Now in series connection, please do not ever forget this very, very important. Current always remains the same, but voltage in series connection would get distributed or will get divided. And finally, the equivalent resistance that you get, that is nothing but the sum of individual resistances. So it's nothing but R1 plus R2 plus R3, so on and so forth. And finally, guys, one more additional point I want you to remember. Is when you want to increase the resistance, you would actually connect them in series. So series connection is used when you want to increase the resistance. Series is used when you want to increase the resistance. When you want to decrease the resistance, that is where the whole connection of parallel comes into the picture. So we'll talk about parallel right now, people. But before that, I hope it's clear again. Please take a screenshot of this. Very, very important, because you're going to need this while you're solving numericals, or even for theory part also is very, very important. So please do not ever forget this. Current remains same, voltage gets distributed, and equivalent resistance is R1 plus R2 plus R3. So R equivalent here is equal to R1 plus R2 plus R3, so on and so forth. And finally, when you want to increase the resistance, that is when you connect them in series. Alright guys, now that is out of the picture. Let's talk about parallel connection now. In parallel connection, what is the type that the resistors are connected? What is the equivalent resistance? What would be the current? What would be the voltage here? So pay attention, very important again. Now, parallel is nothing but this, guys. Parallel is what? Parallel is one after the other. So here one after the other in vertically. So here what happens is, guys, you see this, see in series connection, no, only one end of one resistor was connected to the other end. One end of one resistor was connected to the other end. So basically imagine that this is one end of one resistor. This would be the other end of the other resistor, and that is what is series connection. That is what is series connection. In parallel connection, both the ends are connected. If you just look at this, see this end is also connected, and this end is also connected over here. And if you look at the bottom resistor, this end of this resistor is also connected to the same point, and this end of the resistor is also connected to the same point. So in parallel connection, both the ends of the resistors are connected. In series connection, only one end is connected, right? So this is the major difference between the parallel and series. Now in parallel connection, guys, the most important key terms that you need to remember, or key things that you need to remember, is that, see, if you talk about, let's say there are two resistors connected parallelly, R1 and R2. Let's say that R1 is connected to 2 points A and B. R2 is also connected to 2 points A and B, because there's no other place. No, they're both connected to the same points because they are parallel to each other. So if I find the voltage across R1, if I take it as V1, voltage across R1, if I take it as V1, so what is V1 equal to? The potential at A minus potential at B, just like what we did before. So it's VA minus VB. Same thing goes with R2 also. So if I find out the potential across R2 and if I take it as V2, V2 is equal to VA minus VB again. Sorry, VA minus, I wrote it as AA. All right. Anyways, yes, Avengers assemble. VA minus VB, again VA minus VB. It's V1 is equal to VA minus VB. V2 is also equal to VA minus VB. In fact, guys, if you just look at the way that the battery is connected, the positive terminal of the battery is connected to A, and the negative terminal of the battery is connected to B. So what you understand is this, people, that the potential at A and B will be the same potential provided by the battery, because the battery itself is connected to A and B. So the potential at A and B will be the same as the potential provided by the battery. So here, guys, the key thing that you need to remember is that in parallel connection, the voltage always remains the same. In other words, V will be equal to V1, which will also be equal to V2. So in parallel connection, voltage remains the same, but current does not remain the same. The current gets distributed. Voltage remains the same, but current gets distributed. So what do I mean by that, guys? Just look at the GIF. You'll understand everything. See this? Current is flowing from positive terminal to negative terminal. Once current reaches this junction, once current reaches junction A, you see that part of the current will flow through R1, and the other part, some part of the current would be flowing through R2. So what is happening is that current is getting distributed at that junction A. Now, if you look at the junction B over here now, if you look at junction B, once they flow through, once once the current flows through R2, it'll come to B, and the current that flows through R1 also, after flowing through R1, it'll come and reach B. And once it reaches B, they will again combine together. So what is happening is that, let's say the current flowing through the entire circuit is nothing but I. The current flowing through the circuit is I. Once it reaches A, current flowing through R1 will become I1, and the current flowing through R2 will become I2. So current is getting distributed or getting divided into I1 and I2. But once it reaches the junction B, what's happening is that they are again combining together. So I will again become I1 plus I2. So here current is, the total current flowing through the circuit is nothing but I1 plus I2. I1 is the current flowing through R1 and I2 is the current flowing through R2. So at B, they're again combining together and they're becoming, there you see this in the GIF, you can see that they're becoming I again and they're flowing back into the battery. So here once again, people, this is the base formula that you have, that is I is equal to I1 plus I2. Now once again, we're going to use Ohm's law over here. We know that I is equal to V by R. From Ohm's law, we know that I is equal to V by R. So here, the total current flowing through the circuit is equal to total potential difference applied by the battery, whatever is the total potential difference applied by the battery, divided by the equivalent resistance. Just like what we did before, guys. Instead of drawing it as two separate resistors, I am combining the two resistors and making it as one single resistor of equivalent value. Whatever was the individual resistors, this resistor that I'm replacing it with will have the same value of resistance as before, and it'll have the same value of current, same voltage, everything would be the same. Just that instead of drawing, or instead of putting two separate resistors, I am making it as one single. I'm combining the two and making it as one single resistor, which we call it as the equivalent resistance. So total current is equal to, total current I is equal to the total potential difference applied by the battery divided by the total resistance, which is nothing but R equivalent, and I1 is equal to what? The voltage across R1, which is nothing but V1, and the resistance resistor R1. And if you talk about I2, that is nothing but V2 by R2. So this is what you have. Now we already know this, people, that according to what we just learned right now, we know that here the potential difference remains the same. So V1 is equal to V2, which is equal to V. So in place of V1 and V2, I can substitute that with V. So we have R1, V by R equivalent is equal to V by R1 plus V by R2. Now here, once again, people, all the V gets cancelled on the left hand side and the right hand side. So V gets cancelled. So what are you left with? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. This is the formula to calculate the equivalent resistance in parallel connection. But the mistake is, the most common mistake that I've seen over my years of teaching is this, people, that majority of the students end up forgetting that it's 1 by R equivalent. This is not R equivalent. So once you find the value, you have to reciprocate it. So the actual conversion is, people, if you were to, make it even more in the sense, if you were to cross multiply, because it's in fractions, if you were to cross multiply, you'll realize 1 by R equivalent is equal to R1 plus R2 divided by R1 into R2. This is 1 by R equivalent. You have to reciprocate this. You're cross multiplying this into this, this into this. So when you cross multiply, this is what you're going to get. R1 plus R2 is divided by R1 into R2. But this is 1 by R equivalent. So what is R equivalent equal to? R equivalent is equal to R1 R2 divided by R1 plus R2. This is what you need to remember, people. This is the most important thing when it comes to solving numericals, especially in parallel connection, which majority end up forgetting. It's 1 by R equivalent and not R equivalent. So you have to always, once you find the value, you have to always reciprocate. Do not ever forget to reciprocate, otherwise you'll end up getting the wrong answer. So do not fall into that trap. CBSE again, ICSE board will will reward you with something called as Anda or Puja. All right, if you guys don't do that. So if you have n number of resistors, people, it's the equivalent resistance here would be R by N. So equivalent resistance, if you have n number of resistance, it'll be R equivalent is equal to R by N. So R equivalent will be equal to R by N in this case. If you have n, again, let's say that you have n number of resistors, 100 resistors, each connected parallelly to each other. So it'll be 1 by R equivalent is equal to R by N. So R equivalent is equal to R by N as the resistance. If you have n number of resistors, there in series connection it's NR, that is the N is the number of resistors and R is the value of resistance. Here also it's the same thing. N is the number of resistors and R is the value of resistance, how much ever that is, 3 ohms or 5 ohms or whatever that is, and N is the number. Is it 50 resistors connected one after the other, 100, 200, whatever that is nothing but N. So this is the value to calculate that. So again, people, the key takeaway points that you need to remember in parallel connection is this. In parallel connection, the resistors are connected one after the other, basically vertically they're connected. So both the ends of the resistors are connected. Here current gets distributed, but voltage remains exactly the same. And here, if you talk about the equivalent resistance, is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Now, just to give you an example, guys, for example, let's say that there are two resistors, all right? There are two resistors, each of 1 ohm, all right? Each of 1. I'll just give you an example of why we connect, in series. Why we connect in parallel. So let's say that two resistors are connected, in parallel, and each of them are 1 ohms, all right? Each of them are 1 ohm. So what is the equivalent resistance here? Pay attention. The equivalent resistance would be basically equal to here. It's 1 by R equivalent is equal to 1 by R1 plus 1 by R2. What is 1 by R1? That is nothing but 1 by 1. It is nothing but 1 by 1. So you can add up the numerator, which is nothing but 2 by 1. So this is 1 by R equivalent. So what is R equivalent equal to? 1 by 2, which is equal to 0.5 ohms. So what you need to understand is this, guys. We connect them in parallel when you want to decrease the resistance. When you want to decrease the overall resistance, you connect them in parallel. And when you want to increase the resistance, you connect them in series. All right, I hope it makes sense, people. When you want to decrease the resistance, you connect them in parallel. When you want to decrease the resistance, when you want to increase the resistance, on the other hand, you would connect them in series. So by that, people, we have completed 1/3 of the topics. I hope you have understood whatever we are supposed to learn so far. which is about resistors. Now what we're going to do is we're going to get into electrical energy. What is electrical energy and how do you determine, what is the formula to determine electrical energy? Electrical energy in simple words is nothing but the energy that is produced or is is existing because of the movement of the electrons. So when the electrons are moving from one end to another, or when the charges are moving from when the electric charges are moving from one end to another, that energy possessed by a conductor or a circuit, that is what is called as electrical energy. So for example, guys, imagine there is a simple circuit. I have a resistor R and the potential difference applied by the battery is V. Current flowing through that is nothing but I. So we have already learned this, people, that the battery is doing some work. The battery is doing some work to push these charges from one end to another. So that how do I find this work done? We know that voltage is equal to, or potential difference is equal to, work done on unit charge. We've already studied this in the previous session. So from this I can get the work done. So what is work done is equal to? Work done is equal to potential difference into charge. Now here again, pay attention, guys. Whatever is the work done by the battery, that will be equal to the energy gained by the charges, because whatever work the battery is doing, it is doing on the charges. So what it is doing is it is giving energy to the charges so that it can flow through the circuit, so that it can complete it can go around the complete circuit and go from the positive to negative terminal. That is what the battery does. It gives energy to the electrons to move from one terminal to the other. So I can say that this work done is equal to energy gained by the charge. Because whatever is the work done, the more the potential difference, the more the work done by the battery, more the energy gained by the charges, because the battery is pushing these electrons with more energy. So they get more energy and they start to move with more randomness, or they start to move from one terminal to the other. So that's what happens over here. So energy gained by charge is equal to work done, which is equal to V into Q. So I can say that E is equal to V into Q here. Instead of writing it as W, I can write it as E is equal to V into Q. Now here what I'm going to do is, people, see, finding out charge is a very complicated task. I've already told you this. For example, if I want to find out the current flowing through a conductor, I need to know what the value of the number of electrons in that conductor, and I need to know the charge of an electron. Now, charge of an electron is fixed, but the number of electron is a complicated task, because if you want to find out the number of electron, you need to know the mass of the object, you need to know the Avogadro's number, and you also need to know the atomic mass of that particular element as well, which is a complicated task, right? So instead, what we do is that we are going to divide and multiply this equation with T. So pay attention, people. So what I have right now is this simple equation, that is nothing but E is equal to V into Q. Then what I'm going to do is I'll just multiply and divide by T. Now the value does not change because T gets cancelled and it's basically 1 itself. Now what is Q by T? We know that current is equal to rate of flow of charge. So Q by T is nothing but I. So in place of Q by T, I can replace it with I. So the formula then becomes E is equal to VIT. So this is the formula, the base formula to calculate electrical energy flowing through a circuit. So VIT, you can remember it as Vellore Institute of Technology. That's how I remember it. So energy is equal to what? VIT, Vellore Institute of Technology. That's it. All right. So electrical energy is equal to V into I into T, or VIT. Now there are other formulas for this as well, because instead of E, they have taken it as W, but it's the same thing. Work done by battery is equal to energy gained by charge. So instead of W, you can take it as E, which if it's easy to remember, then go with that. Otherwise, you can write W. There's nothing wrong in it, but I would say E is more appropriate here, because that makes more sense, because you're finding out electrical energy more than the, it's the same thing, but still it would be easier for you to, remember it that way. So the base formula is, people, if you talk about, energy gained by charge, one formula is what? The one that we just saw right now, which is nothing but what? Energy is equal to, or work done is equal to, charge into voltage or potential difference. So V into Q is one of the base formulas. Another formula that we learned is what? VIT. Now, to this formula VIT, we can substitute Ohm's law. So we know that V is equal to I into R. So if you substitute that in the first equation, in the second equation, so you can get as what? E is equal to VIT. So in place of V, I'm substituting I. So it'll be IR. So IR into IT. So this would be equal to what? I square RT. So that's how you get the third formula as well. So if you talk about the fourth formula, again, E is equal to VIT. So in place of I here, we know that I is equal to V by R. So I'm substituting that over here. So E is equal to what? V into V by R into T. So the formula becomes V square T by R, or V square by R into T. So this is the formula. These are all the formulas to calculate electricity. electrical energy. All right, simple. You don't need to by heart all of these, guys. I am pretty sure that I mean, me personally, I don't like by hearting stuff. So if you're someone who's like me, I would say please remember this equation, these two equations. That itself is more than enough. If you can remember the first one, that you can substitute. I would say divide and multiply by t, which can be a little difficult to remember. So if you guys find it very difficult, then remember the first two equations. That's enough. Remember the first two equations. The second and third to aram se you can just substitute the values of I and r respectively, I and v respectively, and get the answer. So if in case in an equation, in a question they've given you the current, resistance and time, then go with this third equation. If in case in a question they've given you the voltage, resistance and time, then go with the third equation. That's it. All right, people. So this is what is electrical energy. Now let's talk about electrical power as well. So this is the third and the final. So we have done 2/3 of the topic right now. We're going to get into the third topic for today, which is nothing but electrical power. What is electrical power? Is it the power that you use to flip over a table when you're angry? No. Is it the power that Thor gets when he lifts his hammer up and says, I have the power in me? No. So what is electrical power? I know, lame jokes, but what to do? Can't control myself. What is electrical power? Electric power is nothing but, guys, power in general. If you remember this from from work and energy and stuff, you probably remember this. Power is nothing but the rate of doing work. Work done at a particular interval of time or with respect to time. That is what is called as power. So the base formula for power is what? Power is nothing but energy by time or work done by time. So what we just saw right now, electrical energy or work done. So power is nothing but work done by time or energy by time, because the energy and work done is very similar to each other. So you can say that power is nothing but rate of doing work, which is nothing but E by T, which is also equal, or we can write it as W by T. Now we just saw that, people, that E is equal to what? E is equal to V into I into T, Vedantu Institute of Technology. So when you substitute that in this equation, P is equal to what? V into I into T divided by T. So from here, people, T gets cancelled. TT say bye bye. So what do you have? You have left with what this equation, which is nothing but P is equal to V into I. This is the base formula over here. Now again, to this equation you can substitute Ohm's law once again. So if you take this as the first equation, power is nothing but work done by time or energy by time, and the second equation is power is equal to V into I, that is voltage into current. So to this equation, if you substitute, so we know that V is equal to I into R. So if you substitute that in the second equation, so P is equal to V into I. So if you substitute P is equal to I into R into I, you'll get as I square R. So this is the third formula for power. And the first formula power is nothing but, we know that I is equal to V by R. So substitute that over here, P is equal to V into I. So that is equal to what? V into V by R, which is nothing but V square by R. So here, people, you have two formulas that you derive from the first formula, that is V is equal to I into I, P is equal to V into I. One is I square R and the other is V square by R. So here, guys, if you just look at this equations, there's one peculiar thing about it. That is, guys, here if you look at it, it says that power is directly proportional to resistance, and here it says that power is inversely proportional to resistance. So the most common question that I get from students is, sir, which of this should I use? Which of this is true? Both are true, people. The only thing you need to remember is, if current is constant, then power is proportional to R. If voltage is constant, then power is inversely proportional to R. So it depends on what is given in the question. All right, it depends on that. If current is constant, then P is proportional to R. If power is if voltage is constant, then P is inversely proportional to R. And the SI unit of this, people, is that, see, SI unit of if you look at the base formula, power is equal to what? Energy by time. The SI unit of energy is joules, SI unit of time is second. So joule per second is the SI unit of power, which is also written as watts. So basically, there was a scientist called as James Watt, and he found out he found out the first ever steam engine. So to honor what James Watt found out, to honor what James Watt found, we are honoring him with this unit, which is nothing but watts. So we also call it as watts, which is represented by the letter W, capital W. So to honor what James Watt discovered, that's what I want. Yeah, I know. I thought about this for a very long time. There was a lot of thinking involved in this. All right, to honor what James Watt discovered, we honor him with this unit, which is nothing but watts. All right, which is represented by the letter capital W. So if you're ever asked to define what is 1 watt, people, there is two ways to define it. One is, we know that power is equal to energy by time, so you can define it as 1 watt is equal to 1 watt. The power is said to be 1 watt when 1 joule of work is done to move in 1 second time. All right, when 1 watt of work is done in 1 second time, that is what is called as that is what is called as power. That is what is called as 1 watt. Or you can also define it as, we know that power is also equal to V into I. So power in a circuit is said to be, electric power is said to be 1 watt when a potential difference of 1 volt is applied, or is applied to move a unit charge, or to move 1 ampere of charge. All right, so, or you can say that when a current of 1 ampere is flowing through a circuit, when a potential difference of 1 volt is applied, that is what is called as 1 watt. All right, so you can either define it this way, P is equal to V into I, or you can define it as P is equal to E by T. It's totally up to you guys. Whichever you feel is more easier, you can remember that. All right, so P is equal to W by T or E by T, and P is equal to V into I. So whichever is easier for you guys, you can remember that. So these are all the formulas, people. We just stated that P is equal to V into I is the basic formula. Then we have P is equal to V square by R, I square by R, and I square R, and then we have P is equal to W by T or E by T. Alright guys, now that you've understood this, people, let's get into the last and the final subtopic of this, which is nothing but the commercial unit of not power, of energy. See guys, for example, imagine there is a simple circuit. Right? Imagine there's a simple circuit. Imagine there's a TV, let's say. All right, let's say that this TV is running for 24 hours a day. All right, let's say it's Ambani's house, because at my home, if I turn on the TV for 24 hours and all, I have to play Matrix, because I'll be, mom would be like throwing stuff at me, so I'll have to move around, like how you play GTA Vice City and all. Anyways, so imagine this is Ambani's house and you're running for 24 hours a day for 365 days a day, 365 days a year. Now, what is power? Power is equal to energy by time. Let's say that the power of this TV is 100 watts, or 100 watts is the power of the TV. The power consumption of the TV is 100 watts. Now, what does this 100 watt represent? First, let me tell you that. What does this 100 watt mean? See, when you go to an electrical shop, people, they'll ask you this question. Do you want a 60 watt bulb, or 100 watt bulb, or 120 watt bulb? Now, what does that mean? See, if I say there's a bulb which is having a power rating of 60 watt, that means that this, bulb consumes 60 joules of energy in 1 second. If I say the power rating of a TV is 100 watt, that means that this TV is consuming 100 joules of energy in 1 second time. That is what it basically means. 100 joules obviously is more than 60 joules. So this means the power consumption of the TV is much more higher than the bulb. All right. So let's say there's a bulb which has a power rating of 100 watts, is running for 24 hours a day for 365 days a year. Now I need to calculate the energy consumed by this TV, because see guys, every every year, not every year, every month. So this is a routine that happens at home, right? I don't know about you guys, but every middle class family has this. So what happens that on this particular day, you get something called as a current bill. Now this electricity bill or the current bill. Now when you get this current bill or the electricity bill, there's this common tendency to blame you for everything. At least in my home, what happens is the day that the current bill comes out, my mom will be like, "You're always on your phone. That is why the current bill is so much. No matter what the problem is always on my phone. It's always on my phone. Whether I have stomach pain, it's because of my phone. Headache is also because of phone. If I'm having a bad day, that is also because of my phone. Anything and everything is dependent on my phone. All right, anything and everything in my home. There's one person to blame. Unfortunately, my phone, who is my companion, unfortunately, he's the one who gets blamed for everything. But yeah, he doesn't have any feelings and stuff, but still I feel bad for him. Now, the question is, people, how do you think these electricity, those people who come to your home and, calculate the bill, how do you think they calculate it? They calculate it based on your energy consumption. So that is what I'm going to talk about right now. How do they calculate this electricity bill? All right, that is why this is very, very important. So people, we know that power is equal to energy by time. So what is energy equal to? Energy is equal to power into time. So if I have to calculate the energy consumed by this TV, what will that be equal to? So energy is equal to, power is nothing but 100 watts, and time for this is running for 24 hours a day for 365 days a year. Now I need to calculate the energy in terms of joules. So if I have to calculate in terms of joules, I need to convert this 24 hours to 24 hours to seconds, right? So 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So into 3600 into 365. Now, when you multiply this, you are obviously going to get a very small number, right? 365 into 24 into 60 into 60 into 100, such a small number. So in order to avoid all this, people, because this is going to be a huge value. So instead of, and this is for one single device. Now imagine how many devices are running currently as you speak. Like at this point of time, there are at least 5 devices that you can name which is running while you're watching this video, right? So if you add them all up together at the end of the month, you'll be getting values in trillions, which is basically more than India's GDP at times, right? And that is for one house. So instead of doing all this harkat, what we do is that we convert from joules to kilowatt hour. So here is the thing, guys. So basically we know that power is equal to, so energy is equal to what? Power into time. The SI unit of energy is joules, SI unit of power is nothing but watts, SI unit of time is nothing but seconds. So all I'm doing is that, see, in whatever value, for example, guys, let's say that I'm just giving you a random number over here. Let's say that this one I got it as, let's say I got it as 1 crore. All right, I got it as 1 crore. All right, this is how much? This is 10 lakh. Let's say I got it as 1 crore. Let's say I got it as 1 crore. All right. Now, 1 crore is a very big number. 1 crore joule is a very big number. So instead of writing it as 1 crore joule, can you also write it as 1 crore, how much is this? 1 crore watt second? It's still the same thing, no? Because 1 joule is equal to 1 watt into 1 second. So instead of writing it as joules, I can write it as watt second. So what I'm doing is, people, I'm converting from watt second to their higher units. So the higher unit of watt is nothing but kilowatt, and the higher unit of time is nothing but seconds is nothing but hours. So all I'm doing is that I'm converting from watts second to kilowatt hour to their higher unit. So in place of writing it as instead of writing it as joules, I can write it as kilowatt hour. So 1 watts, people, 1 watt is equal, 1 kilowatt is equal to 1000 watts. And 1 hour is equal to what? 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So that's 3600 seconds. So when you multiply the two, you can see that 1 kilowatt hour is equal to 1 watt into 1 hour, which is, or 1, watts into second, which is nothing but 1000 watts into 3600 seconds. When you multiply these both, you'll get it as 36 lakh, right? 36 lakh joules, which can also be written as 3.6 into 10 to the power of 6 joules. So instead of writing it as 1 crore joules, what you can do is, people, you can just divide this by 3.6 into 10 to the power of 6, joules, and you can actually convert it into kilowatt hour. Getting it? So this is the commercial unit of energy. So at homes and in offices and all, what we do is that we actually convert it to kilowatt hour, so that it's much more easier for calculation, because joules is going to give you a huge number. So instead, what we do is that we convert it to kilowatt hour, and we represent it. So at home also, if you've ever seen those electric meters, no, they actually measure it as kilowatt hour. They don't measure it in terms of joules. They calculate it in kilowatt hour. Now what they do later is that 1 kilowatt hour is equal to 1 unit. So for example, in Bangalore, let's say that 1 unit is equal to 5 rupees. All right, 1 unit is equal to 5 rupees. So whatever is the energy consumption, for example, let's say that for that particular month, your consumption was around 400 kilowatt hour. So 400 kilowatt hour is equal to what? 400 units. So what will be the cost then? The cost will be equal to what? 400 into 5 rupees. So 4 5s are 20. So that means that the electricity bill will be around 2000 rupees. All right. So this is how they calculate the, the bill, and they give it to you, and that's how you get scolded every month. All right. So that's it, people. That was the entire chapter for the of current electricity. I hope it makes sense. I hope you understood it. I hope you enjoyed it. If you did, do not forget to like, share, subscribe, and let your friends also know that there's a channel called as Vedantu's 9th and 10th English channel to help you guys out with your preparations, where everything is done for free with absolute and complete openness, right, guys? Now, if you guys want more help with your preparations, people, because I know that a lot of you guys are panicking at this point of time. It's a very common thing, right? And it's a see, there's 2 things that you can do right now, people. Either you can panic and mess up your exams, or you can collect your thoughts, gather your thoughts, focus on your preparations of your term 2 examination. Now the choice is yours. What I would say is, there's no point in worrying about stuff at this point of time. There's no worry. There's no point in expecting your exam to get cancelled, or there's no point in worrying about what can possibly go wrong, because there are a billion things that can go wrong. There are a billion things that can go wrong. Now, if you think about each of those things, you will never see. If you just think about it, it takes a lot of willpower to wake up in the morning, right? If you think about all the problems that you're going to face on that particular day, and if you just keep on, hanging on to those problems, you won't even feel like you. None of us would wake up from our bed itself. Would be stuck over there. But life is not about that, people. You need to get up, you need to face your challenges, you need to face your fears, and you need to go forward, right? That is what life is all about, right? And in order to help you with your problems, because I know that your problem, the biggest problem that you guys are facing right now is your preparations for your board exams, right? And that comes with a lot of challenges. Because of COVID-19, you're not able to go to school. So that means the biggest problem that you're facing is getting your doubts solved, right? Because you might know the concepts because of all the things that is going on in Vedantu's 9th and 10th English, Vedantu 9th and Hindi channel. There are a lot of things going on. So that means that your doubts are the biggest problem that you have. Getting your doubts cleared has become a very, very, very big problem. Some of you guys might still be having or lacking that conceptual clarity that you require. Some things which are confusing, which are very integral to your preparations, but you're still lacking that preparation, that level of preparation. That is something that you guys are lacking. Maybe you just need more assignment questions and questions to practice to get better at the topic. Or you might be looking for a revision plan. No matter what your problem is, no matter what state you're in, whether you're someone who've already started the preparations, whether you've already you're in your revision cycle right now, or you've not started it at all, it doesn't matter, guys. We at Vedantu are always here to help you out, to help you, to guide you in the right path, to make sure that you're getting the best of everything. So in order to help you become better, to make you better every single day, we have our own online session that is going on parallelly, right, on Vedantu's platform. Now, let me tell you what are the advantages and why Vedantu. Out of all the things that is there out there, why should you choose Vedantu? The first thing is, people, you just like how it is on YouTube, you can always watch the recording of any session at any time. So, for example, let's say you missed out a session due to some health reason, you can always go back and watch the recording if in the past sessions. You can even check out whatever sessions you have upcoming also. Whatever sessions you have for that particular day, you can check that out as well. Not only that, people, we didn't just stop there. We went on to make sure that the whole process of learning is a little bit more enjoyable. So we make sure that we have a lot of riddles and questions to make you interactive, or to keep your brain active at all times, to make sure that the whole process of learning is not necessary the whole process of learning has to be boring or it has to be monotonous, right? So in order to make it interesting, we always start with the riddle, we start with a code, something of that sort, to kickstart your brain of yours. And to keep it interactive, people, we make sure that you always are doing something or the other, either by thumbs up, thumbs down. We always keep it always interactive, and you have the hotspots, you have questions, quizzes, and based on these quizzes, you have fastest fingers list, which tells you how fast you've answered with respect to your entire class. You'll have stars for every right answer you get. You have leaderboards, drum rolls, you have confetti shots, you have balloons flying up and down, you have applause, lots and lots of amazing stuff. And every day, literally, guys, every single day, we're trying to find out better ways to make ourselves better, to make it more interactive, to make your life much more easier. Because it is not necessary, guys, that the way that we studied, it was conventional, right? We were not taught to enjoy learning the concepts. But here at Vedantu, we make sure that you also enjoy the process of learning as well. And that is the whole motto behind Vedantu. The motto behind Vedantu is this: maza aayega to samajh aayega. It means if you are enjoying the concepts, then you also end up learning. So you have leaderboards to ensure that you're staying motivated throughout the sessions. You have even the option to talk to the teacher, which is something which is missing on YouTube, right? You can't really talk to the teacher. Here you also have the option to talk to the teacher, get your doubts cleared right there and then, without having to worry about carrying your doubts to the next session, or having to forget about that doubt altogether because you don't have a source to get it clear. Not only that, people, we also have the option to get your doubts broadcasted as well. So imagine there's a doubt that I feel like, or a certain teacher feels like, the entire class can benefit out of it. So they even have the option to broadcast that doubt, which means that the entire class would be able to see that doubt and get the answer for that doubt as well. And not just that, people, I promised you that we'll be solving your doubts, right? So in order to help you with that, we also have someone called as a class teacher. So every session, you would have the master teacher who you see, but there are other people behind the screen as well. So we have someone called as a class teacher who will be there behind the class, who you really can't see, but they are there, who are equally qualified to ensure that your doubts are being solved. You heard that right, people. Inside the class itself, you'll have two set of teachers to clear your doubts. So to give you an example, in a particular session that you see over here, there were about 88 doubts that were asked by students. And if you look at it, all of those 88 doubts were resolved inside the class. So no more doubt. That 88 doubts, those students, whoever had those doubts, it was completely answered. And about 14 doubts were broadcasted, which means the entire class could see that doubt as well. So that is what Vedantu is providing you. And yes, you can download the notes, people. Always just the click of a button. If you go to the past sessions, click get notes, and the entire thing would be downloaded like this as a PDF, and you can refer to that whenever you want. And not only that, people, we have stress relief sessions, we have entrepreneurship sessions, we have debate classes, we have yoga sessions. So we have not just stopped at academics. We have, focusing on the all-round development of each and every student. That is what you're getting from Vedantu. Right, guys? So if you want to be a part of it, if you want to kickstart your journey right away, people. So this is the first, current electricity one-shot series. Make sure you check it out. Make sure that you hit the like button, subscribe to the channel as well. And yeah, this is for the first one, so you can check that out as well. That is the first few topics that we did, if you haven't checked it out already. So what you have to do, guys, is go to ICSE Crash Course full syllabus that you see over here. Avail exciting Vedantu or courses. So just click on this link and it will direct you towards the Vedantu's webpage, where you can check out everything for yourself. Complete full syllabus revision course for grade 10. All of this that I just talked about, everything included until the end of your examination. That is, you're getting at a nominal price of just 8,775 rupees. I know that it seems like a lot of money, but think about it, people. You're getting, all the major subjects, and you're getting all these features for just 8,775 rupees, and that is till the end of the year. Now, if you're like, sir, 8,000 is a little too much, I can't really pay so much, then guys, try the 1 month program. Because if you go for the 15-day program, the 15-day actually increases to 1 month. All right, 15 days is actually 1 month. So even though it is 15 days, if you use my coupon code AME Pro that you see over here, you are actually going to get 10% off, and the time frame that is there, would actually increase to 30 days. So instead of 15 days, it will become 30 days. You in fact get even more 10% off if you use apps like MobiQuick and all. You'll be getting even 10% off. So that is about, you can get up to 1,000 rupees, cash back over there also. 10% over that also you'll be getting. So in total, you'll be getting 20% off, including the app, which means that you're paying just 1,170 rupees, and 10% of that again you'll be getting a cash back of that as well. So this whole month of one whole month program of Vedantu that you're going to get for all the subjects, every feature. So that means that in that 1 month, you would have completed at least 60 to 70% of your syllabus, right? 1 whole month, you're just getting it for 1,170 rupees. And trust me, guys, that is amazing. That is super amazing, because just think about it. I mean, where I passed out my 10th standard, a couple of years ago, right? I think in 2011, 2010 is when I passed out. Now, I also studied in ICSE school, and I know that each class, I remember that for mathematics also, I was forced to go to tuitions at that time. So for mathematics also, I used to pay like 500 rupees per subject. For every subject, it was 500 rupees. For every subject, it was 500 rupees. Here, you're getting all the major subjects for 1,170 rupees for the entire month. Trust me, guys, there's no better deal out there. And more importantly, there's no one else who can help you and guide you in a better sense than the amazing teachers over here. all right, because we put our heart and soul into it. And you can see that on the platform on YouTube itself. If we can do so much on YouTube, what do you think we can do on the paid sessions? Just think about it. All right. So anyways, guys, let's do some quiz questions right now. We'll do a couple of quiz questions to test your knowledge, because we've done so much. Have you guys really understood something or not? Let's check that out. Now, let me know in the comment section how many questions you were able to give the right answer for. All right. Let me know in the comment section how many questions you get the right answer for. So here's the first question, guys. A parallel combination of resistor is used to obtain what? Smaller resistance, low voltage, high voltage, or high resistance. When you connect, resistors in parallel, what is it that you get? Do you get smaller resistance, low voltage, high voltage, or high resistance? I'll answer the quiz in 10 seconds, people. If you guys need more time, pause the video and then take more time. Take as much time as you want, but get the right answer, and don't skip through it, and don't directly go check out the answer. The answer in 3, 2, 1 is going to be smaller resistance, guys, because when you connect the resistors in parallel, the equivalent resistance is going to be less than the individual resistances. Next one, the commercial unit of electrical energy is what? What is the commercial unit of electrical energy? Horsepower, joules per hour, kilowatt hour, or megawatt hour? What is the commercial unit of electrical energy at homes and all that? How do we measure electrical energy consumed by that particular household, by all those electrical devices? Very simple. I've already stated this again. We have done it in detail over here. So horsepower, joules per hour, is it kilowatt hour or megawatt hour? I'll end the quiz. I'll answer the question in 5, 4, 3, 2, 1. If you guys need more time, pause and then give the answer. The answer is, guys, again, kilowatt hour. The unit of energy, the SI unit, is nothing but joules, but the commercial unit of electrical energy would be kilowatt hour. All right, because it's easier to measure it like that. Okay, here's another one, guys. Two bulbs A and B are connected in series with a cell. They're connected in series. A and B are connected in series. Resistance of a bulb A is RA and resistance of bulb B is RB. What is the ratio of current in bulb A and bulb B? Is it RA is proportional to RB? Is it proportional, or is it RA, RA by RB? Is it 1:1? Is it RA is to RB, or is it 1:1? Is it RB is to RA, or data is insufficient for you to find out the ratio of current flowing through these resistors? Very simple question. It looks very complicated, such a big question. Trust me, guys, this answer is so silly, so simple, so jujube. Trust me, if you get it wrong, no, you would yes, I'm not going to complete the sentence. You complete it. Fill in the blanks with your suitable words. But yes, the answer to this question, guys, in 5 seconds, I'm going to give you. Pause the video, get the right answer. They are connected in series, which means that the current flowing through both the resistors would be exactly the same. And if current flowing through both of them is same, then the ratio is what? 1:1. Because in a series connection, current would be the same. Current does not have any other path to flow. So the same current will be flowing through RA and RB as well. So the ratio will be 1:1. Last question, people. Joule's law of heating. Oh yes, guys, I'm really very sorry. I think I forgot to say this. Once I answer this question, people, I've already stated the formula, but I don't name it. All right, but I'll just tell you anyways. So here's the question. Joule's law of heating effect of electricity establishes a relationship between what? Joule's law of heating effect of electric current establishes a relationship between current and area of cross section of the conductor, current and length of the conductor, current time for which the current passes through the conductor, resistance of the conductor, or current and time for which the current passes This again is something that we have already learned, but I've not specified this. So what is heating effect of electric current is nothing but, guys, when current is flowing through a conductor, you have to probably notice that your adapters, things like that, would heat up after some time. When you turn it on for a very long time, be it your phone, be it your charger, it becomes hot. This is what is called as heating effect of electric current. So basically what is happening is that when current is flowing through a conductor, there is heat energy produced. And this heat energy is produced because of resistance. It is because of resistance. So we know what resistance is. When electrons are flowing through the conductor or charge is flowing through a conductor, it will collide with other ions and other electrons, and they'll lose energy, and that energy that is lost is actually in the form of heat. Understanding? So electrical energy is converted into heat energy then. So here, guys, what is Joule's law of heating? The answer to this question is actually option number C. Why? Because according to Joule's law of heating, people, Joule's law of heating, which is represented is represented by heating effect of electric current is equal to I square RT. So this is what is Joule's law of heating. So that means that heat energy produced in a circuit is directly proportional to the square of the current flowing through the circuit. Heat energy produced is directly proportional to the resistance, and heat energy produced in a circuit is directly proportional to the time for which the current is flowing through the conductor. So these are the three factors that it depends on, and this is what is called as Joule's law of heating. In fact, guys, the other formulas are exactly the same. Remember the formula of energy? It is the same formula that you're using over here. So E is equal to VIT is what we learned before. This E is equal to VIT is nothing, can also be written as H is equal to VIT, because whatever is the energy gained by charge, we know that work done by battery is equal to energy gained by charge. The more is the work done by the battery, the more is the energy gained by the charge. The more the energy gained by the charge, the more energy it loses in the form of heat, because there'll be more number of collisions, because it has more energy, it is more excited, so it'll have more number of collisions, and more energy is the loss in the form of heat. So it's the same formula as whatever we did for energy. You just have to substitute the value, substitute for Ohm's law, and you'll get the three equations that we got, the same equation that we got for energy. We'll use it over here as well. All right, so that's it, people. That is all for today. Thank you for spending your time with me. I wish you guys all the very best of luck, and I wish you guys all the power in the world. Good luck. See, guys, again, I would say that please don't wait till the end of the year to start your preparations, or till your exam dates are announced. Start your preparations right away, and you have an opportunity, an amazing opportunity to kickstart your preparations right away. And I would say do not waste that opportunity and make use of it, right? So catch you guys in the next one then. Take care of yourselves. Peace out. Again, as always, like, share, subscribe. I'll catch you guys in the next one. Until the next time we meet, this is Anoop signing off for the day. Adios for now. Take care. All the very best of luck. Let me know how the session was in the comment section below. All right, guys. See you soon. Take care. All the best. Good luck.